Have you ever wondered about how we came to know about what the smallest particle of matter is? It was not until about 460 BC that a Greek philosopher, Democritus, began to develop the idea of atoms. He asked this question: if you break a piece of matter in half and then break it in half again, how many breaks will you have to make before you can break it no further? Democritus thought that it ended at some point, a smallest possible bit of matter, and he called it atomos, which means cannot be divided. It was more than 2,000 years later when a scientist, John Dalton, proposed the atomic theory of matter. His theory, unlike the one of Democritus, was based on experimental observations. The main points of Dalton's theory are that matter is made of atoms, and atoms are indivisible and indestructible. All atoms of a given element are identical in mass and properties. Compounds are formed by a combination of two or more different kinds of atoms. A chemical reaction is a rearrangement of atoms, and atoms can be neither created nor destroyed. It's important to realize that the atomic theory is really the result of many scientists, including Joseph Proust, who came up with the law of definite proportions, which people nowadays kind of refer to as the Lego-ness of matter. He believed that matter could be put together in certain patterns to make bigger, different, and unique matter. The law of definite proportions states that a chemical compound always contains exactly the same proportion of elements by mass. As scientists began to understand more about the structure of the atom, they became very interested in organizing the known elements somehow. Although many people contributed to this effort, Dmitri Mendeleev is known as the father of the modern periodic table, not because he was the first or the only scientist to do so, but because he recognized that patterns occurred in the periodic table. And in fact, he was so sure about these patterns that he left a space for elements that were yet to be discovered. Although we still use the basic ideas put forth by Dmitri Mendeleev, our periodic table today looks very different. We know about a lot more elements, and we know a lot more about each one of them. As you look at the periodic table, it's important to note that for each symbol, the first letter is always a capital letter, and if there's a second letter, it is always a lowercase letter. The symbols for elements can show up in some very unusual places. By the way, there are 7 elements on the periodic table that never exist as single atoms. They are always either in a compound or exist with each other as a 2-pack or a diatomic molecule. The easiest way to remember what they are is to look at the periodic table. Start at element 7 and make a 7. Plus, add in that hydrogen. Another easy way is to make yourself a shirt.